Oh, and let me get that erased. That wasn't important to anybody, but it's right where my projector is. Go. Okay. All right, we are recording. I almost have the projector on. We'll go from current slide. And there's a couple of little announcements. Last time, I'm pretty sure I said that I was going to bring a key and tape it up here. And I was searching all over my office this morning, and then vaguely in the back of my mind, I remember a few years ago, someone needed a key to this, and I said, well, use this, but get it back to me once you get issued one. And I don't even remember who it was, so I don't know if I can get it back or not. I think I know, so I'll try to see if I can get it. But otherwise, we don't have the key. Now, there's another, and this is sort of one of those good news, bad news situations. Oh, boy. I don't know. I think I know where to press it here, but I got far. Input terminal, everything seems to be hooked up correctly. Let me fiddle around with some of these. Okay. Okay, there we go. Yes, okay. Amazing. I did something with technology and it worked, okay. Doesn't happen often. Okay, mark the day. All right. I was talking about a good news, bad news situation. The bad news is Monday's a holiday. The college is closed. No classes Monday. The good news is it doesn't affect us any, does it? We meet on Tuesday, Thursday, so we don't miss a class. So rejoice, and let's move on. Okay. I'm going to keep my roll here even though it's in the way. We were at example 2. The book doesn't do example 2. It really should. This is one of the most important ones, but, and I think I pointed this out to you several times before, but I'll point it out again. Example 2, if you'll notice right under the example, oh, and I did get everybody your course code, right? Did anyone who's here today who was here last time did not get the course code, class code? Okay. Let me put it on the board for you right now, and let me mark you in the book. What's your name, please? Okay. Got it. All right. All right. I don't know if it's bad on that pen to get hot. I don't know. Okay, the class code is, hey, can I get your name, please? Brian? You said Brand? Brown, okay, got it. Deja Brown, okay. I should have seen that. Okay. Now, for any who weren't here last time to get the course code, here is the course code. Let me get my pen set up. All right. Lawson, Lawson, .al. I can't imagine what that stands for. And then, in what they sent me, it had a space. I don't know if it's important or not. 2709. Then another space, 2966. Is that the number I gave y'all Tuesday? Okay, well then it should be the right one. Okay, so that's our class code, course code, whatever they call it, that they ask for when you try to access whatever, the ebooks, WebAssign. Now there's some problems out there on WebAssign. I did not select them. I told the guy at Cengage to do whatever he wanted to with those, that I wasn't going to assign them, but I wanted you to have access. Can I get your name, please? Well, oh, Walt. Good. Good deal. Okay, and by the way, there's the class code for the course. If you are doing the Cengage Unlimited, you need that. But I told the guy I want, put whatever problems you want out there. I told him how I usually assign things. I said I'm not going to use it as an assignment, but you can use it for extra practice. And they have, I've always heard they had really good tutorial help on WebAssign. But then I had a student in one of my classes yesterday that said, well, except for the one-on-one stuff, you can ask a question and it might be an hour or more before you get in touch with, anyone gets in touch with you. So he found the one-on-one tutorial stuff that they brag about less than pleasing. But I think the online tutorial stuff I think is quite good. Okay? So that gives you access to all that if you're on Cengage Unlimited. Okay. Now let's get back to example 2. And what I was saying about it, and this is one reason I don't do WebAssign, especially for this course, because this author provides every bit of the help you could possibly want. Example 2, even though it's not on the slide set, if you'll notice, it says, see larsonprecalculus.com for an interactive version of this type of an example. I would definitely go and interact with that website. It's free. You don't need a code. You don't need anything. You don't even need to be in the course. You don't need to buy a book. You can go, anyone can go to larsonprecalculus.com. Now, you have to know your way around to get there, but hope y'all are young, you're tech savvy, you can find your way there. Go to section 1.4, example 2, and you'll see examples like this. And these are key. Why they didn't have it on the slide set, I don't know. So anyway, here is example 2. Determine whether, remember we were talking about whether an equation, a formula, or something like that, whether it's a function or not. Okay? Now we said for any single x, there's only one y. Okay? That's the definition. But for a continuous function, or even a discrete function that has a huge number of values, you can't test every one. Okay? Continuous, there's no way. You can't test every point between 0 and 1. Because there's an infinite number of points on a continuous function between 0 and 1. Between 0 and 0.1. There's an infinite number. There's no way you can test them all. So here's how we do it with equations. Here is the A one. Okay? X squared plus y is equal to 1. All right? Now, how do you determine whether that is a function or not? That y is a function of x. Say again? Have to what? Separate them. What do you mean by that? All right. Very good. Notice what we said. Is y a function of x? Y is a function of x. Well, then you want to isolate exactly what you're saying. Isolate the y. So how do we do that? Subtract x squared from both sides of the equation, right? That wipes out there. That goes to 0, and you have y is equal to 1 minus x squared. Now the question is, if you give me an x, any x, how many y's do you get? 1 and only 1. Because for any x that you plug in there, there's only going to be one y. That's it. 1 minus x squared. Whatever x you put in, it gives you a value. Only one value. So yes, that is a function. How about this one? minus x plus y squared is equal to 1. Can I get your name, please? Ashley, got it. Okay, I know exactly where you are. Okay, you're right there. Okay, never mind. Okay. Ashley's here. All right, good deal. All right. Very small podium up here. Okay. So, what would you do with this one? The question is, determine whether each equation represents y as a function of x. So what would we do? Solve for y. Okay? And what would you do to accomplish that? Did I hear add x to both sides? Yes, that's what I thought I heard. Add x to both sides, and that gives me, that goes to 0. Y squared is equal to 1 plus x. Well, there's y is isolated, but it's y squared. I don't care what y squared is. I want to know what y is. So how do we undo a square? Second, take a square root. So we take the square root of both sides of the equation. Okay? Now, square root of y squared is y. Why not? Okay? But when you take the square root of both sides of an equation, what must you remember to do? Plus or minus. So this is plus or minus. So it's, get out of there. Okay. Plus or minus the square root of 1 plus x. All right. Now, give me an x. Say again? 2? Is that what you said? 3. Okay, I like 3 better. Okay? If you put in a 3 for x, 1 plus 3 is 4. Square root of 4 is 2, but you got a plus 2 or a minus 2. Whoops! What's wrong with that picture? Yes, for 1x, 3, you get 2 y's, plus 2 or minus 2, not a function. Okay? Now, they leave this sort of vague here, but let me just give you a hint. If you're trying to find y as a function of x, if that y is squared or raised to any even power, it's not going to be. Okay? You can guarantee that, because anytime you take a root of an even power, you get a plus or minus. Odd powers, no sweat. Okay? They can still be functions. Okay? Now, if it started off being a root, you may have problems there too, but yeah, that is one dead giveaway. That's not going to be a function. If it's to an odd power, the odds are it is going to be a function. All right. Now, not only was the example, you can get an interactive version of that type of example at LarsonPrecalculus.com. There's also a checkpoint. After every example in the text, every one of them, there's a checkpoint with a couple more similar to the ones you just did. And guess what? Audio, video solutions in both English and Spanish are available at LarsonPrecalculus.com. So man, he has more study aids, tutorial, that kind of stuff than any other book I've ever taught from. I don't know this author, but I like him. Okay? Don't like the company, but I like the author. All right, any questions on that? Okay? And those tutorial help, I think, would be quite good. So if you're having problems with it, check that out. All right, when using an equation to represent a function like we just were, if it is a function, it is convenient to name the function for easy reference. My favorite is Sam. No, I'm just kidding. That's not what you name the functions. Okay, for example, you know that y is equal to 1 minus x squared. That wasn't the one we had, but it's pretty, oh, it was, wasn't it? Yeah, that was the one we just had. Okay, y is equal to 1 minus x squared. So, if you want to name that function, the most popular name, okay, I thought someone was coming in. The most popular name is not Bill, okay, it is f for function, okay, f of x. That's what we usually name it. Then you can use this following function notation. If the input is x, or anything else, it could be y, it could be M, it could be A, it could be B, it could be stickman, it could be anything you want it to be, okay? If the input is that, the output is f of x. Remember my black box that you crank, sausage grinder? The output is your f of x. And guess what? Now this is the one thing to remember in this course, dealing with functions, that's the most important thing to remember. Y is equal to f of x. In standard thing, when we do xy notation, x is the independent variable, y is the dependent variable, vertical is dependent, y is equal to f of x. If you remember that, you've got most of functions knocked. You got it in the palm of your hand. So instead of saying y is equal to 1 minus x squared, you write it as f of x is equal to 1 minus x squared. Okay? It's that simple. Okay? So you have an equation, solve for y, just like you were having me do, and then instead of y, write f of x. You've got it. There it is. Okay? Any questions on that? Okay? To me, the most important thing to remember, y is equal to f of x. Now, if you have other variables like interest is equal to 1,000 R, we had that one before, then your y in that one is your I, and the R is your x. Okay, so I is equal to f of R then. Okay, or g of R. You don't have to use f, but that's the most popular name. All right, the symbol f of x is read as the value of f at x, whoever says that, or simply f of x. That's what I've been calling it, and that's what it always is. And by the way, that handsome little character at the top of the page, if you're looking at your book, Leonard Euler, he's the one who came up with this notation. Thank you very much. Okay. And the symbol f of x corresponds to the y value. So there it is. So you can write y is equal to f of x. That, to me, is the most important thing to remember in functions. Okay? Keep in mind that if f is the name of the function, f is the name of the function, whereas f of x is the value of the function at when the value of the output when the input is x. Okay? So f of x is equal to 3 minus 2x. Give me an x. 4. So what is f of 4? What would be f of 4? Okay, what we would do is everywhere you see an x, you put a 4 in its place, because you just put 4 instead of ooh. Where is it? There it is. No. There it is. Okay. You do 3 minus 2, and there's an x, so put a 4 in its place. And what is that? Yes, negative 5. That would be 3 minus 8 is equal to negative 5. Okay? They gave us a few. What is f of minus 1? What would that be? For this f here. Help me, help me. For this f right here, what is f of minus 1? Oh, it was a long time ago I said how to do that, wasn't it? Okay, you don't have to do it in your head. Just tell me what to write. You do 3 minus 2, and then where you see an x, you put in a minus 1. And that would be 3, say again, plus 2 equal 5. Okay, we like our 5s these days. Okay, how about 0, my favorite? F of 0. What would that be? Tell me how to get it. 3 minus 2 times 0. And what would that be? 3, because 2 times 0 is 0. And one more, let's do f of 2. Okay, already got it done before I can even write it down. 3 minus 2 times 2, which is 3 minus 4 equal negative 1. Y'all are absolutely right. Well, there it is, y'all. See how that works? Now, is this podium in the way for people over here? Yeah, got it. All right. Because I could move out in the hall. No, just kidding. Okay. All right. I didn't say that. Any questions on that? You see how he does do it. Now, here's a key, and it's going to show up time and time again. Whatever you're evaluating that goes in the parentheses there next to the F, that goes everywhere the variable does in the expression. And guess what? You can put all sorts of weird things in there. You could put a stickman in there. You do F of stickman is equal to 3 minus 2 stickmen. Okay? You can put anything in there you want to. It doesn't have to be a number. It could be anything you want to. That doesn't make any sense, but you can do it. Who said you made sense? No, I didn't say that. Okay. So, y'all don't have to write that last one down. Go ahead. I'm just kidding. Okay? The book's going to go over that in a minute. They're not going to use stickman, but they'll use something else. I just like stickman. It's hard to draw with. All right. Anyone need it any longer? Okay. Don't let me go too fast. If you don't get everything, say, hey, put that back. And I'll put it back. And here's how they did it. Alpha negative 1. They do 3 minus 2 times negative 1. Wherever you have taught x before, put a minus 1. 3 plus 2 is 5. Alpha 0, my favorite. 3 minus 2 times 0. 3 minus 0, 3. You don't have to do all the steps if you don't have to. If you can do it in your head, that's fine. Just make sure you got your head on straight, okay? And if x equal 2, alpha 2 is 3 minus 2 times 2, 3 minus 4 is minus 1. Perfect. Okay, although alpha is often used as a convenient function name, x is often used as an independent variable. I've been saying this before. You can use any other letters you want to. Now, I wouldn't use x of x. That's just too confusing, okay? So any other. So that means that these various expressions here, alpha of x is equal to x squared minus 4x plus 7. That function is exactly the same as the function alpha of t is equal to t squared minus 4t plus 7. All you did was instead of x, you put in a t, and everywhere you saw a t, you put in a t. That's the same thing. Same thing. Doesn't matter. Actually, your independent variable, you thought, independent, that's important. They're dummies. They can be anything you want them to be. Okay? And you can change the name of the function and the change of the name of the input variable. And g of s is s squared minus 4s plus 7. It's the same function. You just change the name of it, but it's the same function. They all define the same function. In fact, the role of the independent variable is that of a placeholder, or some people who are derogatory say dummy variable. Okay? And that's exactly what it is. Okay? Now, anything you want to put in there, you can put in there. I think it's going to come up maybe. Yeah. I don't know if they're going to do it. We'll see if they do. Let you finish writing. Pregnant pauses. I don't know what they're called. I just made that up. And by the way, that leads me to something else. I'm trying to recall now. I think in this class I got the PowerPoints posted on Blackboard. Did anyone check and see? I've got 6 classes, and I can't keep straight which ones I've done what to. If they're not there yet, they will be. Are they there? Okay, good. I thought I had gotten this one done. I don't have my trig class done yet, but I have this one done. So guess what? If you want to print all these PowerPoints out ahead of time, then you can take notes on them. Some people like to do that. I never bothered, but, you know, some people like to do it. That saves yourself a little bit of writing. But on the other hand, okay, writing it down is a better form of learning than just reading it, okay? Reading it is passive, writing it is active, so you still may want to write it. That's up to you. Okay, here's the other one. I use Stickman, they use gray rectangle, okay? Alpha of gray rectangle is gray rectangle squared minus 4 times gray rectangle plus 7. Anything you want to put in there, you can put in there. It's the same function as the one we had before. Okay, I'm not going to mark it here twice. Okay, so a function is defined. Okay, this sentence here doesn't go on this slide. It goes on the next slide. I don't know who did that, but before we get to that, let's do example 3. So let's go back and see if we can find space to do example 3. I think I'll do it here. So let me erase this. All right, and let's do example 3. All right. Again, this one's this is a crucial one, and why they left it out of the PowerPoint, I don't know. Here's g of x. G of x is equal to minus x squared, okay, this is your sausage grinder, plus 4x plus 1. Not quite the same one we were using before, but pretty close, okay? It says find each of the function value, the a one here. Pretty straightforward. What is g of 2? You tell me what to do. You don't have to do it all in your head. Tell me what to write. Whoa! Don't do that. No. I don't like this podium because I can't lean on it. Buttons get pushed. What is g of 2? Tell me what to write. Minus 2 squared plus 4 times 2 plus 1. Everybody agree with that? All right, perfect. Everywhere you saw an x, you put a 2 in its place. All right, now here's the big question. What is minus 2 squared? Okay, I heard a 4, and I heard a negative 4. Oops, which one is it? Okay? Okay, now, let me say this. Does anyone remember the little acrostic saying, please excuse my dear Aunt Sally, or Sue, or whoever she was, and whatever she did, I don't know, but please excuse her, okay? Now, what did that stand for? Parentheses first. This one doesn't have any parentheses. Well, I put in a parenthesis. We'll get to that. Then exponents. You do exponents next. There's an exponent. So we do, and then we have multiplication, division, and addition, subtraction. That subtraction is the last thing you do, so therefore the minus sign, leave alone, square first, excuse before Sally, okay? So that's minus 4. See it? Next. What's next? Say again? Plus 8, plus 1. And what is that? Oh, there you go, and do it again. What's that? 5. Excellent. Okay? Yeah, now you can do it pieces at a time. Minus 4 plus 8 would be minus 4 plus 1. Plus 4 plus 1 would be 5. Okay? Technically, the multiplication, divisions, and addition, subtraction, you do left to right. Yeah. Okay? Everybody got it? But if they're all additions, subtractions, all multiplication, division, you can do them in the order you want to. Because they're commutative and associative. Well, subtraction is a division, but never mind. Okay. All right, so there was g of 2. Okay? The B part says do g of t. And what would g of t be? Goodness gracious. G of t. We go back to g of x. What would g of t be? Negative t squared. Help me. Plus 4t plus 1. That's it. Just everywhere you saw an x, you put a t instead, right? Pretty simple, right? Now, here's the kicker. Okay, here's the C one. What is g of x plus 2? What? Can you do that? Sure you can. If you can put a stick man in there, you can put an x plus 2 in there, right? So what do? Tell me what to write. Negative. Now I'll put this in parentheses, x plus 2 squared plus 4 x plus 2 in parentheses plus 1. Okay? Now I guess you could leave it like that, but no, we really need to simplify that a little bit. So how would you go about simplifying that? Okay, just as before, leave that minus alone until the very last step, right? Dear Aunt Sally. Sally is the very end. Subtraction's at the end. So leave that alone, and let's do the parenthesis of the exponent first. Does anyone know, just looking at that, what x plus 2 squared is? If you don't, that's okay. You can go over here to scratch work and do it on the side. Anyone know what x plus 2 squared is? Not? Well, then how do you calculate it? What does x plus 2 squared mean? X plus 2. What does squaring something mean? Multiply it by itself, okay? So times x plus 2. Now, when you write it like that, what can you do? Curses foiled again, okay? You can foil it. Y'all don't know what I'm talking about there, do you? Y'all don't remember? No, I'm talking about curses foiled again. Rocky and Bullwinkle. One of the fun. Yeah, you ever heard of that? Yes, okay. One of the best cartoons ever. Okay, that was back when I was young. Just really wild. Okay, that's what Boris and Natasha always said. Curses foiled again. Okay, you do the first, foil. That would be x squared. Then you do the outer. That's the O part. And that's plus 2x. Then you do the inner. That's plus 2x. And finally you do the last. Remember, F-O-I-L, foil. Last is plus 4. Okay? And besides having, where did that go? Okay. Nope. Yeah, there it is. Besides having a smiley face, even though it has a crooked chin, what do you have? Combine like terms, what do you get? X squared plus 4x plus 4. Okay, let me tell you what you just did there. You squared the first digit. Ooh, can't touch that, can I? X squared. And then you did twice the product of the two digits. 2 times x is 2x. Double that and you get 4x. And then you squared the last one. 2 squared is 4. So that's the shorthand. If you forget the shorthand, you can always go back and forth. Okay? Anytime you're squaring a binomial, square the first, twice the product, square the last. Okay? So that would be x squared plus 4x plus 4. Okay? All in parentheses behind that minus sign. Now you can multiply this through. What does that give you? This is called distributing. What's that? 4x. Help me. Plus 8. And then you can put your plus 1. Okay, now we finally distribute the minus sign across the parentheses. I'm running out of room rapidly. Let's see if I can do it over here. What would that give us? Minus x squared. Help me. Minus 4x minus 4 plus 4x. I'm running out of room. Plus 8. Oh, let's just add 8 and 1 and make it 9, okay? It's cheating a little bit, but it's not a bad cheat, okay? Let's just change. Oh, the eraser didn't work. Okay. So let's just make that a plus 9. Save some room here. Oh, that's not a pen. All right. Now, what do you notice what do you do next? I know that's sort of ugly, but combine like terms. Now, the only x squared term I see is minus x squared. But I see two x terms, and what are they? Minus 4x plus 4s. What does that add to? 0, nothing, not a thing. Okay, so just leave that alone. And then how about your constant terms? Plus 5. Perfect. There is g of x plus 2. Doesn't look at all like g of x plus 2 or your original function, but there it is. Does that make sense? All right, and again, that was a really key one. Yeah, don't be shocked if you see something like that on the test too, or a quiz or something like that. This is important stuff, and they skipped it on the PowerPoint. But they do have a checkpoint there, gives you another one to do like that, and that one has audio video solutions at larsonCalculus.com, precalculus.com. Okay? Now, any questions on that before I beat it to death? Okay? Let's move back to that last line. That should be on the new slide. A function defined by two or more equations over a specified domain is called a piecewise defined function. Okay? And I think they're going to give an example of that. Let's see. Yes, here's one. F of x has two different definitions. One is for x's that are negative, anything less than 0. The definition is x squared plus 1. But then it has another definition for 0 or anything positive from there, and that would be x minus 1. So we need to evaluate that function, that one function there, at three different values. Okay? So let's first do f of minus 1. And what would that be? And here's where you have to stop, pause, and ask yourself, where are you, Waldo? Okay? Now, what I mean by that, you remember that, huh? Okay. Where is negative 1? Is that less than 0 or greater than or equal to 0? Less than 0. So you use this one. Forget this. It's not even pertinent now. So you do that. You plug, and guess where you plug the minus 1 in? The x squared plus 1. Don't mess with the other one. Just plug it in. F of minus 1 would be, what do I plug in? Minus 1 right there. It's less than 0, so you plug it in there. What would that be? Everywhere you see an x, plug in a minus 1. What do you do to that minus 1? Square it, and then add 1 to it. Right? That's what the function tells you to do. Right? Now, in this case, notice I put the negative 1 in parentheses because the x is being squared. The minus is not separate. The minus is part of the x. And what do you get when you square minus 1? You get 1. Plus 1 is 2. You didn't know you'd be doing such high-level math today, did you? 1 plus 1 is 2. Okay, we got it down. Nice. Okay. Now it says do it when x is 0. F of 0. Where are you, Waldo? Top one or bottom one? Bottom, because x equals 0, you use the bottom one. So what do you plug in here? 0 minus 1. And what's that? Negative 1. Does everybody see that? And why we did it? You first figure out where you are in the piecewise defined function, and then you use that definition. Make sense? All right, let's do 1. F of 1. Where are you, Waldo? Top or bottom? Bottom again. So what would you plug? 1 minus 1, and guess what that is? 0. Good deal. Okay? Does that make sense? Okay? Can I delete it? You'll see it again because they're going to do it too. Okay, here we go. Because x equal -1 is less than 0, you use f of x equal x squared plus 1 because that's where you are. You're in the top echelon there because x is less than 0. -1 is less than 0. So you plug it in here. F of -1 is -1 squared plus 1, which comes out being 2. Okay? Just like we got. They skipped a step or two, but that's okay. All right. Then for x equals 0, you're no longer upstairs, you're on the second one. Because x equal to 0, you use x minus 1, plug it in there. F of 0 would be 0 minus 1, which is, of course, minus 1. Make sense? Just what we did. It's nothing new. It's not different. It just isn't as neat as mine, isn't it? No, never mind. Okay, don't answer that question. Okay. So, and the last one, f of x equal 1. Again, you're in the lower one, so f of x is x minus 1, which is 1 minus 1. 0. Nothing. Absolutely nothing. Any questions? See how it works? First figure out where you are, then use the value for that. Where does the x fit in? There is a checkpoint, so why don't you be sure. And that's a good thing to do, by the way. If this stuff's a little fuzzy and hazy to you and you're not quite sure of it, as soon as you have opportunity after class, whenever you have a free moment, get to the library or the lunchroom or somewhere, an empty classroom, sit down and do your checkpoints. Because we've just done things just like them in class. Do the checkpoints. If you can't figure it out, if you have a computer, go to, and that might be a library, you can use the computers there, go to larsonprecalculus.com and see why you're not grasping that. Okay? So, let's move on to example 5. Oh, they skip example 5 and 6. So let's back up and we'll do examples 5 and 6. All right, example 5. Find all the real values for x. Ooh, this is a really crucial one, and they leave it off the slide set. I can't figure it, okay? Find all the real values for x for which f of x is equal to. So we're trying to find the x. There it is. No, that's not what we mean, okay? For which f of x is equal to 0, okay? When a f of x is equal to negative 2x plus 10. Okay? There's your function. And we want to find the x that makes that f of x equals 0. How would we do that? Say again? Oh, wait. That got in there. It shouldn't have gotten there. Okay? What would you do? Say again? Right. Okay. That may be what I'm thinking. Right. Notice what it says here, where f of x is equal to 0. Okay? But this is your f of x. That's your f of x. And guess what we do? Set it equal to 0. And then find the x that makes that a true statement. That makes sense, doesn't it? So instead of f of x, we put a 0. 0 is equal to minus 2x plus 10. Is that what you meant by writing it backwards? Yeah, I thought that might be a good way to think of it. Now, how do we find the x? Say again? Okay. Now, that's a good idea. What we want to do to find the x is isolate the x. We don't want x mixed up with anything else. In other words, we want a naked x, nothing else around it. Okay? Now, I know your name, but I can't think of it now. Had a good idea. Jake. Jake said, move the 2x. Well, that gets it by itself on the other side. So how do we move it? We pick it up? No. Say again? Add 2x to both sides. That's a legal algebraic thing. Add 2x to both sides. Okay? 0 plus 2x is 2x. And that's equal to minus 2x plus 2x. For some reason, my pen's not writing. Okay. Okay, that adds to 0, and then you have just 10. And then what can you do? You want to isolate the x. Divide by 2, because that was multiplied. And that gives us x equal, say again, 5. Okay, let's see if we're right. Let's plug in a 5 for your alpha of x. Alpha 5 would be minus 2 times 5 is negative 10 plus 10 is 0. Ding, ding, ding. Got it. We found the x that made that function equal to 0. Does that make sense? All right. Do what it tells you to, okay? Set alpha of x to 0, make it 0. Let's see if we can do this next one. Alpha of x is equal to x squared minus 5x plus 6. Okay? Get out of there. Okay? Now, this is the B one. Okay? That was A, this is B. Okay? What are we going to do first? Have they told us to? Okay, wait. Set it equal to 0, because alpha of x is equal to 0. That's what we're doing. So set this equals 0. This I'll put on this side then. I think that's what you meant before. And just forget about it over here. We just moved it over there. All right? Now, how? Okay. I understand how to solve an equation when it's x to the first power. We call those linear equations. Just isolate the x. What do we do when we have a quadratic or higher power? Say again? Foil? Is that what I heard? Okay. Actually, unfoil. Okay. I like your thinking there, but it's actually doing it in reverse. What you have to do is get it into this form where it's equal to 0, and then what we call, okay, now, I don't want to offend anybody, and if this is offensive, I won't say it ever again. But in this class, when I say, what is the F word? It's going to be factor. Is that okay? Now, if y'all get offended by that, I won't say it anymore. Okay? Y'all okay with it? So that's what we do when you have a higher power there. You see if you can factor it. Okay? Y'all probably think of that about the same as that. No, I won't go there. Okay. So, can we factor that? And this is what I call unfoiling. So I think you're right on the money back there. Okay? Now, it has to equal 0. Okay? If it doesn't equal 0, move it so it does equal 0. Before, you moved everything away from the x. Now you move everything toward the x. Okay? Is that factorable? Yes. How do we factor x squared? X times x. That's why we're unfoiling. Start with the first, unfoil that. Okay, but here we don't spell too well. We go to the sign of the last term. Not the L, but last term, but the sign of the last term. What is that? Plus. Now that means these two signs here have to be what? They either both have to be plus or both have to be minus. So where do we look to determine? The middle one. That means they both have to be minus, minus, minus. Okay, now we're looking for two numbers that multiply to be 6 and add to be 5. 2 and 3. Why not? Okay? 2 and 3. Okay? Now, here's why we set it equal to 0. Anytime you have a product of any number of entities that's equal to 0, what do you know about those entities? One of them's got to be 0. Exactly. You can't multiply any two entities together and get 0 as an answer unless one of those is 0. So we then say, let's say, x minus 2 equals 0. Or x minus 3 is equal to 0. One of those got to be true. Otherwise, the product wouldn't be 0, right? So how do we solve the first one? Add 2 to both sides. And what does that give us? Say again? X equal 2. And over here, add 3 to both sides, and that gives you x equal 3. We got two answers. Is that legal? Of course, you can have more than one x give you the same y. You can't have one x giving you two y's. So either x equal 2 or x equal 3. Well, let's see if that's indeed true. What's 2 squared? 4 minus 5 times 2. What's 5 times 2? 10. 4 minus 10 is? Negative 6 plus 6? 0. And how about 3? What's 3 squared? 9. Minus 5 times 3 is? 15. 9 minus 15 is? Negative 6 plus 6 is 0. Yes, yes, yes. They both work. So there you found all the x's that made that f of x equals 0. Does that make sense? Okay, as soon as you can, if this is fuzzy to you, after class, if you have another class, wait till after that one's over with, but at some point, go and do your checkpoints. Here's a checkpoint. And it's a very similar type problem. And if you can't get it, there's audio-video solution at larsonprecalculus.com. All right, let's do 6. Can I erase this one? Everybody got it, or anyone need it a little longer? Everybody got it? Yay or nay? Okay. All right. Okay. Example 6. Another really key one. Find the values of x for which f of x, you're looking for x, so find x such that f of x is equal to g of x. Okay? And the A problem here is where f of x is equal to x squared plus 1, and g of x is equal to 3 minus x squared. No, 3x minus x squared. Okay? Did I write it right? I hope so. That's one of the biggest errors you can make is copying it wrong. Okay? Now, how do we approach a problem like this? Say again? Absolutely, that's what it says to do. It's where it says where f of x, and here's what f of x is, x squared plus 1 is equal to g of x. Well, here's what g of x is, 3x minus x squared. You just do what it tells you. Okay? And now what can we do with that? What can we do? Say again? Okay, how do you simplify that? Okay, now, first thing I do, I'll look and see, boy, my exponents are 2 or more. So now I want everything on one side and 0 on the other side. If the only exponent was a 1, I want the x's on one side and everything else on the other side. But this has an exponent of 2, so I want everything on one side or the other. Now, here's my little rule. You don't have to do this. You can do it any way you want to. I look at those x squared. You've got one on each side. This one's positive. That one's negative. I always go with the bigger. And positive is always greater than negative. So I'm going to move it this way. Once I move the x squared this way, everything else has to come this way too. I go with the biggest term and biggest exponent and then decide which way I want it to move. So if I'm going to get the x squared on the other side, how do I do that? Add x squared to this side, but to be democratic about it, you have to add x squared to this side as well. Okay, now you can do it in 1 step or 2 steps. I don't care. You can go on and move the 3 if you want to. You want to do it now or wait and do it later? Do it, Do it now, okay? How do we move it? Subtract 3x from both sides, so I'll subtract 3x here too. Now I have to do, that's not squared, okay? Don't do that. Don't make up something, okay? All right. Now, I got a little manipulation to do to the left-hand side. Here we have x squared plus x squared is 2x squared, and we have just one that's minus 3x, and then we have a plus 1. So we got everything that we got on the left-hand side. And what's left on the right-hand side? That goes to 0, that goes to 0, 0. Ha! That's just what I wanted, isn't it? We want all the things on one side. Now, what should we try first? Factor. Good. Okay. And again, we're going to use my little unfoiling rule, which I take it is probably what, was it Jalen that said that? No. What's your name? Okay. Yeah. Okay. So anyway, what's the only possible factorization for 2x squared? Go with the first. 2x times x. Very good. Okay. Now, we jump to the last term, and we go to the sign of the last term. What's the sign of the last term? Plus. That means these two signs have to be the same. What do they need to be? Both negative, because the middle one's negative. So minus, minus. Now we have to, okay. What's the only factorization of 1? 1, okay? Now, if this doesn't work, that means it's not factorable, because that's the only possible factorization. Let's see if it works. Always go back and foil it once you've unfolded it to make sure you did it right. So 2x times x is 2x squared. Yeah, that got us right. Then you do your outer, and that 2x times minus 1 is minus 2x, and the inner is minus x, and minus 2x minus x is minus 3x, and minus 1 times minus 1 is plus 1. Yes, that worked perfectly. If it didn't work, are you through? Are you washed up? You can't do anything else? If that factoring didn't work, if you can't possibly factor it, are you through? Are you dead in the water? No. What could you use? Oh, this is digging way back. Quadratic formula. Yes, our favorite, right? So you could use that if factoring doesn't work. But it did work, so we won't worry about that until a later day. What do we do next? Okay, set each of them equals 0. Because the product's equals 0, one of them's got to be 0. So either 2x minus 1 is equal to 0, or x minus 1 is equal to 0. And the first one, what would you do? Second, add 1 to both sides, and that gives you 2x is equal to 1. And then what would you do? You want to isolate the x, divide by 2. And what does that give you? You get x equal? Say again? 1/2, exactly. So there's one answer, x equal 1/2. Is that legal? Can we have fractions? Of course we can. Just as good a number as any. We don't like them as much, but we can have them. And on the second one, what do we have? X equal 1. If you can do it in your head, do it. If not, add 1 to both sides, and you get x equal 1. Okay? 2 possible solutions. I like to go back and check because I want to make sure I got right answers. Okay? I don't want you giving me wrong answers. Because if you have all right answers on quizzes and tests, they're so much easier to grade. So I want you to give me all right answers. I'm lazy. I don't like grading hard stuff. So get them right so it makes it easier to grade. Okay? Deal? Okay. So let's check it. I almost have to come over and check it. Okay? So let's plug in a x equal 1/2 here. What is 1/2 squared? 1/2 squared. 1/4 plus 1. 1 1/4 or 5/4. Okay? Y'all got that? Hang on to that. I'm not over there, so I can't write it. Okay, what is g of 1/2? 3 times 1/2 is? Say again? 1 1/2 or 3/2 minus, and what was that 1/2 squared? 1/4. So if you had 3/2 minus 1/4, well, 3/2 would be 6/4, right? Minus 1/4. 5/4. Yes, that worked. That was a hard one. Let's do the easy. F of 1. What is 1 squared? Plus 1. Yeah, y'all remember that from before, didn't you? Yeah, 1 plus 1 is 2. Got it. How about here? 3 times 1 is? 3 minus is? Yes! Okay, both of those work. We found the 2 values of x such that f of x is equal to g of x. Make sense? All right. I'm out of room, so what I want to do is do the b part. So I'm just going to erase parts of it. I'm really lazy, you can tell. Okay, I don't want to write any more than I have to. Okay, I don't get paid by the word. Okay, never mind. I didn't say that. Okay, this takes longer than if I just erased it all, wouldn't it? Okay, all right, done. Okay, and let's do the B part. In the B part, alpha of x is equal to x squared minus 1. Get out of there. Okay? And g of x is equal to minus x squared plus x plus 2. And we want to find all the x's that make alpha of x equal g of x. So what do? Set them equal to each other. Alpha of x is x squared minus 1. That's what it says here. And then you put an equal sign. Then you write what g of x is. Well, g of x is this. Minus x squared plus x plus 2. We've just done exactly what they told us. Alpha of x equals g of x. Alpha of x is that. G of x is that. Set them equal to each other. And then we proceed as before. What would be your next step? Add x squared to both sides. So you've decided to move things to the left. So add x squared to both sides. You better move everything to the left. And what does that give you? What do you do next? Subtract x from both sides. There's no x over there. I'll just put it there. And you subtract 2 from both sides. I'll put it under the 1. Okay? It's sort of out of order, but we'll deal with that. So when you combine like terms there on the left-hand side, what you get? Oh, goodness gracious. I've got to find it again. This thing drives me nuts. Is that it? I think it is. Okay? That gives you 2x squared. Now let's get the x in there. Minus x minus 3 is equal to 0. Good. That works out well. And then what do? We hope and pray it's factorable. If not, we use, y'all forgotten already, quadratic formula. Actually. Okay, now what's the only possible factorization for 2x squared? 2x times x. And where do we look next? Sign of the last term. And what is that sign? Negative. Uh-oh, this is a little more complicated now. How do we get a minus? One's plus and one's minus. Okay? We don't know which is which. So we guess. This is called trial and error. Which way you want to write it? Plus first and minus second, or minus first and plus second? I don't care. Second, negative first and plus second. Okay? Now, all the possible factorizations for 3. Again, we have choices. So it's trial and error. You try something. Which you want first? You want 1 or 3? Or 3 or 1? I don't care. Help me. Second? 3 first. Okay, he's cheating. Okay. And 1 second. All right. Let's check it now and see if it works. 2x times x, we're foiling it now. I'll go on and foil it. 2x times x is, I'm going to write it up here. 2x squared. That's right. That's what we had here. Now we do the outer to here, and what does that give you? Plus 2x. Okay, the inner gives you minus 3x. Okay, and the last gives you minus 3. And when you combine like terms, you get 2x squared minus x minus 3. I knew he cheated. Okay, no, I'm just kidding. Okay? Yes, that's exactly the right factorization. Now, let me give you a couple of hints here. You probably already know this, but I'll give them to you anyway. Okay? You pay me to talk, I'm going to talk. Okay. If when you did this, you get the wrong number here, then change numbers. But when you do down here and you just get the wrong sign here, change signs. So, wrong number, change numbers. Wrong sign, change sign. That's a little trick that I think usually comes in pretty helpful. Okay? But you got it right, so there's no, can't teach it, never mind. Okay, so what do we do with that? Now we got our factorization. So I'm going to remove my construction lines here so it'll be easier to read a little bit anyway. Okay. Whoops, I erased my parentheses too. Sorry. Okay, where do we go from there? Okay, we set each of them equals 0, 2x minus 3 equals 0, or x plus 1 equals 0. Okay, can we do anything with that first one? We're wanting to isolate the x. So what do we do? Not yet. Always deal with the plus. Yeah. Add 3 to both sides. Okay, and that gives you 2x. That adds a 0 is equal to 3. And then you divide by 2, and that gives you x equal 3/2. I can't wait to check this one, okay? And over here, what do you do? Subtract 1 from both sides, and that gives you x equal, because that adds a 0, -1. Okay, that's not going to be too bad. The other one, I'm not sure I want to do it, but let's do it anyway. Okay? What is 3/2 squared? Anybody? 3/2 squared. Yes. 9/4. Excellent. Okay? And we're going to subtract 1 from it. But you know, that doesn't subtract too easily. So rather than 1, I want to subtract, how many fourths is 1? 4/4. So 9/4 minus 4/4 is 5/4. So remember, this one's 5/4. Didn't we have that before? Ooh, strange. Okay? Now this one. What's minus 3/2 squared? -9/4 plus, okay, 3/2 is 6/4, isn't it? Right? That makes it easier to add. So -9/4 plus 6/4 is, write it down if you need to. Say again, -3/4, okay, plus 2. Now how much is 2? How many fourths is that? 8/4. Okay? Have I done this right? I got to write it down. My head's getting sore trying to remember this. So that's going to be, okay, what do we say? -9/4 plus 6/4 plus 8/4, right? Isn't that 2? Okay. Get out of there. Okay. That would be -3/4 plus 8 is 5/4. Okay, we got it. 5/4 on both sides. The -1 is even easier. What is -1 squared? 1 minus 1 is 0. Hey, 0, right? Okay. The next one, minus a -1 squared. Ooh. That would be minus a -1 squared. What would that be? -1, and then plus a -1. That would be -2 plus 2 is 0. Yes, so both sides are 0. Have we run out of time? How sad. Okay. So next time we'll start with, oh, there's a checkpoint at the bottom. Please do your checkpoints. Next time we'll start with the domain of a function. Okay. Top of page 40. Okay. Before you go, since it's a holiday weekend, we want plenty of homework exercises. So, let's see. At the end of the section, okay, do any of the odds, either 5 or 7. They're both at calcchat.com. 7's at CalcView. Do number 9 is at CalcChat. Do any of the odds, 11 through 17. You can hear it on YouTube if you want to. And that's all of them at CalcChat. 11's at CalcView. Do any of the odds, 19 through 29. They're all at CalcChat. 21's at CalcView. And then evaluating a function, do either 31 or 33. They're both at CalcChat. Finding values for which f of x equals 0, which is one we did just a little bit ago. Any of the odds 35 to 41, they're all at Calc Chat. 37's at Calc G. And then F equal G, that's the one we just did, either 43 or 45. They're both at Calc Chat. 43's at Calc G. If you listen to YouTube, you'll hear them. Okay? It's on pages 44 and 45. And if you need to take a picture of mine, if you don't have that, you can. Okay, why don't you do it? It's any of the odds from all up to right here. So I'll get out of your way. Okay, let me get out of here. Okay, get out of your way. Okay. I'm sorry? Oh, okay. Do you have your book yet, or yeah? Okay, it's basically your odd number.
So he just do all the odds.
Okay. Oh, do I need to take it up?
Yeah, that's
It's only if you're having problems.
Oh, okay.
That's not 7 to 9.
Okay, that's right. Yeah.
So
Okay.
you said,
Yeah, I repeated those again today.
Oh, okay.
Yeah.
Thank you.
Okay.
So you said do 11 through 19
Okay. Odds in this group, odds in this group, that's only one. Odds in this group, odds in this group, odds in this group, odds in this group, odds in this group. Huh? That says 43 or 45. Okay, it's not 46. Yeah, that's no. Yeah, odd numbers, 5 to 46. But you don't have to do them all. Do some and hit through.
Just to make sure that you know how to do it.
Yes. And if you get them right and say, okay, I can go on to the next group. And if you have trouble with it, anytime you have trouble with any of them, you can bring them to me. We'll go on together.
These on that website too.
You'll hear it on YouTube video. Yeah. If you listen to the video, you'll hear me say all those problems.
So all what you just did, that's on Blackboard, right?
It'll be a Blackboard on the YouTube video. I can't remember. Do I have that link there?
I haven't checked.
Did it? Huh?
It is.
Okay. You see each group here?
No, you can say it, but we about to have our first organization. We might have an organization meeting tomorrow. Organization meeting tomorrow. Yeah.
Odd numbers, yeah. And stop at 46. We haven't done that. Okay.
Yeah, thank you.
Yes, sir. You can, but I grade what I get. So if it's not in the format you want it, looking at the screen, you might not see some problems with it, whereas it's printed, but I'll take it. Whatever you send me, but I grade what I get. Okay.
I know what you mean, but like I'm talking about, like I email.
Yeah.
I'm trying to get it done today.
Second.
I'm going to try to get it done today.
Yeah. Okay. I understand. Right. Okay. All right. Good deal.
See you there.
All righty. I was going to say you're going to see me again.
I know.
Okay.